Hi, in this video we're going to start looking at capacitors in circuits. So we're going to look at the RC circuit. The circuit looks like this, and basically we have a voltage source and we have a resistor and we have a capacitor. And there is a special thing here. Our voltage source is a DC source, and here we have a switch, and we're gonna have the switch open at the beginning, and then we close it so that the circuit is closed, and we leave it closed for a while, and then we open it again, and we want to see what happens. So this basically is describes what we call step function, because as we close the switch, we suddenly have a step and something happens to the circuit, and then we open the switch and then the step is gone and something else happens to the circuit. And we want to see what that is. So in previous videos, we already saw what a capacitor is, and we saw what the characteristic function of the capacitor is. We're going to use that to solve this circuit. So as we can see here, we have in this case, three elements that are connected in series. We have our voltage source, our resistor, and our capacitor. We have our input voltage, and our output voltage we want to calculate here in the capacitor. And since they are connected in series, they all have the same current. So we are going to use Kirchhoff's voltage law, which is the mesh rule, to calculate the voltages here. So we would have our mesh equation will be minus VI plus the voltage in the resistor, which is R times I, plus the voltage in the capacitor, which is our output voltage, and all that is equal to 0. Now, we know that we can represent the voltage in the capacitor with the characteristic equation in terms of its current. So we know that the current is the same for all of them. So we know that this current is also the current in the capacitor. And we know that the current in the capacitor is described by this equation. So the current is the capacitor times the derivative of the voltage. So we put this in here and we get I'm going to change color now. RC times the first derivative plus our capacitor voltage equals our input voltage. And this is our equation that describes our circuit. Now, this is, of course, a differential equation, and within the limits of this course, we're not going to look at how differential equations are actually solved, but we're going to, in the next couple of videos, I'm going to show you what the solutions are. Basically, the solutions depend on the initial conditions that we have on our circuit, and the solutions will describe what happens to our circuit. So that's it for this video, and thank you very much.